Okay, hello everyone. You're welcome. We are going to be discussing about matrix. A matrix or matrices, which is the plural form, is a rectangular array of numbers enclosed by a pair of brackets, which is arranged in rows. So it's arranged in rows and columns. So wherever you see an array of numbers arranged in rectangular form or in the form of a rectangle, and there are entries there, it can be numbers, it can be letters, it is referred to as matrix. So we have an example here. You can see from here, like I said, it can be numbers, it can be letters, but the main thing is that it is arranged in a rectangular form. So we have A, B, C, D. Then we have 1, 2, 3, 4, 5, 6. There's something important they said here, rows and columns. So we have the horizontal array. So this, for example, this is row 1, this is row 2. So when you are arranging, you can see this is horizontal, is for rows. Then the vertical is for columns. So this is column 1, column 2, and column 3. So here is row 1, row 2, column 1, column 2. So this one has 2 rows and 3 columns. This one has 2 rows and 2 columns. So we have that the entries inside the bracket are called the elements. So this is row. The horizontal side is called the row, while the vertical arrangement is called the columns. Then these entries, this A, B, C, D, are referred to as the element of the matrix. These 1, 2, 3, 4, 5, 6 are referred to as the element of the matrix. So we have what is called the order of a matrix. Order. When they are talking about the order of a matrix, it is they are talking about how the rows and the columns is arranged or has been arranged. And it's important. We always refer to the rows first before the columns. The rows first before the columns. So take note of that. So we have, for example, if you are asked the order of this matrix, you start from the row first. The order of this matrix, this is row 1, row 2, row 3. That is 3 by. So we call it 3 by something. So this is 3 by. This times means 3 by. So let's count the columns there. 1, 2, 3, 4. So the order of this matrix P, we can write it like this as P is equal to, or we can come here and write the order as the row is 1, 2, 3. 3 by 1, 2, 3, 4 by 4 matrix. It means that it has 3 rows and 4 columns. Then coming to this place, how many rows are here? The order is 1, 2 rows. So this is 2 by, how many columns are here? 1, 2, 3, 4 and 4. So this is 2 by 4 matrix. So for you to be able to understand this topic, you have to know what are rows and what are columns. The rows are the horizontal arrangement, while the columns are the vertical arrangement. We'll go to types of matrices. We have many of them, but let's focus on these 4 major types. As time goes on, we get to see even what is called singular matrix. We have a whole lot of them. So we have the zero matrix. This is the type of matrix whose entries are all zeros. So whenever you have a matrix that the elements inside are all zeros, it is referred to as zero matrix. Remember what we did here. This A is matrix A, and this T means 2 rows, 2 columns. You can say I have 2 rows, 1, 2, and 2 columns, 1, 2. So that is why the order is 2 by 2. Then we have 3 by 3. You can see we have 3 rows and 3 columns, and all the entries there are 0. So when you have all the entries there are 0, it is referred to as a zero matrix. Then we have square matrix. The square matrix is when the number of rows is equal to the number of columns. You can see here I have 2 by 2 matrix. So the number of rows is equal to the number of columns. The number of rows is equal to the number of columns there. So there's what they always say that the square matrix, maybe when we'll in our next class we'll talk about that. So let's go to the next one. We have what is called the non-square matrix. The non-square matrix is when the number of rows are not equal to the number of columns. we'll see as many of them as possible in this our class. When the elements row is not equal to the column, it is referred to as non-square matrix. You can see that what is the order here? This is 2 by 3. The numbers are different. Once the number of rows and the number of columns are different, it is non-square. But once the number of rows and the number of columns they have the same number, it is square matrix. Then identity, it is denoted by this I in capital letter or just normal I, which is called the some textbook or some will call it the unit matrix. So this identity is 2 by 2, for example. This order is 2 by 2. What does it mean to be identity matrix? It has 1 as elements in the main diagonal and 0 in other elsewhere. Look at what I mean. This is called diagonal. This is a diagonal. This is a matrix. This diagonal is called the leading diagonal. Are you seeing that now? So you can see 1 and 1 is here, but in elsewhere we have 0. This is the leading diagonal. You can see 1, 1, 1. Others are zeros. So when you have this kind of scenario, it is referred to as identity matrix. For example, if I have, let's say 1, 1, 1, 0, let's say 0, 0, 0, 0, 0, 0, 0, 0. Is this an identity matrix? Let's check it. This is the leading diagonal. You can see from here is not identity matrix because this one has 0. It can only be identity if this 0 is 1. You can see in this leading diagonal, all of them, all the entries there, all the elements there are 1 and elsewhere are 0. But if I put 0 here, let's say I have something like 0 here, it is not an identity matrix. Even if I have 1 here and I have number apart from 0 that's like another number that is not 0, it is not identity. So identity is it has 1 as element in the main diagonal or leading diagonal and zeros elsewhere. So in our next class we are going to learn how to add and subtract in our matrix, and the order is very important. So make sure you understand what is order and make sure you at least know these 4 major types of matrix. As time goes on, we are going to discuss other types. See you in the next class.